to lead our conversation on sample size justification. I think such a relevant topic for all of us, and until reading this paper, I think I'd never really considered just how many different ways there are to approach this. So we're probably at a bigger number than we normally are for Journal Club, but let's see how it goes. Let's try and keep the conversation as open as we can. But Cyril, as I said, I can keep an eye on the chat during the conversation and let you know if something's happening. And yeah, let's go.
Okay, so hi everyone. I hope the audio is right for you and you hear me correctly. If it's not the case, you can just send a message on the conversation and I will like repeat. Okay, so yeah, we are here today to discuss the last preprint that Daniel Lakens wrote and post on the network. That is about some sample size justification. So the presentation will be divided in two parts. So in the first part, I will just summarize in 2 or 3 slides the most important things that we can that will be kind of a basics for everybody to discuss. And then I prepared 4 discussion steps. So with question that maybe situation we may face on our research life, and that could be useful to discuss and resolve all together. So as AMRC, we will try to keep the discussion as open as possible. And yes, don't hesitate to just say hi and discuss whenever you want. So the very first question when we talk about sample size estimation is, why do we estimate a sample size? Actually, there is currently 3 reasons that came to my mind when there is this question. The 3 main reasons are, first, that we want as researcher to estimate the resources we will expend in a study. So do we need to expend 1 year, 2 years, 3 years on the resources? Do we need to collect 1, 10, 20 person? Do I need 1, 2, 3 intern, 1, 2, 3 PhD to work on a project? So the very first question we try to answer is we try to estimate the sample size because we need to estimate the resources we want to expend on the study. The second reason is different, is because of the journals that more and more today require a priori sample size estimation more often. This is something most reviewers begin to ask to the authors. And so one reason is that the journal will most probably ask you, why did you recruited X 10, 20 participants? And the very final reason, that is really interesting and that the paper discuss is to estimate the informational value of a study. So the idea is that when you will have a result on a study, you would like to know whether the results you observe, the inferences you observe, are they trustful, are they meaningful, or are they not reliable? And so the sample size estimation will help to estimate the confidence you can have on some results. But currently, there is a difference that is important to keep in mind, is that there is a difference between estimate and sample size and justify and sample size. And today we are here to discuss the real question: how do we justify a sample size estimation? When we have an estimation of a sample size, how do we justify this estimation? And this is what we aim to discuss today. If we have a look on the paper that on the preprint from Daniel Lakens, so the preprint is called Sample Size Justification and focus on the justification process. The question we could have today is, us as sport and exercise scientists, should we change our sample size justification practices? And the second question we can have, as sport and exercise scientists, how could we enhance our sample size justification practice? Do we have the best practices? And if not, how could we move forward? The paper we will discuss today is rather long, so I choose to focus only on one part of the paper, the beginning, with the sample size justification methods. If we observe the literature, there is commonly 6 methods to justify a sample size, ranging from the lowest accuracy to justify a sample size to the highest accuracy to justify a sample size. When you are at the lowest level of accuracy, there is the first one that is no justification. You estimate that you don't have any reason to justify a sample size. The second possibility is to use heuristic rules to justify a sample size. For example, you hear that somewhere in the literature, a colleague told you that you need 20 participants to justify a sample size. This is what is called a rule of thumb. It's an heuristic rule that you can use to justify a sample size. Another possibility you have is to justify your sample size based on resources constraint. You have some resources available, you have a time available, you have an amount of money available, and you are constrained by these resources. So this is another way to justify the sample size. Then you can justify your sample size based on an a priori power analysis. So you will estimate, you will justify your sample size because you want to reach a certain level of probability of finding an effect, assuming there is an effect to observe. Then you can estimate you can justify your sample size based on the accuracy of a parameter, for example, the width of a confidence interval. And the last possibility is to measure the entire population. For example, as a sports scientist, we may face this situation. We want to work with top level athletes. We know that there is only 10, 20 top athletes in this sports. And so we justify our sample size because we will measure the whole population. Currently in the literature, the most common practices are the heuristic justification, the resources constraint justification, and the a priori power analysis that are good balance between convenience and easy to use. However, if you have a look on the paper, it is rather the best way to justify the sample size is not the heuristic and the resources, but the paper focus mostly on the a priori power analysis that could be considered as reliable and convenient way to justify sample size that should be considered more often in the time. So this is really the introduction of the paper with the 6 methods to justify a sample size. And then, so these methods will fit with everybody, which means that anybody here with any researches we can conduct, we will need to justify a sample size, and we can use one of these 6 methods to justify the sample size. Then on the paper, if you have a look at it, there is other part that will be only meaningful depending on particular situation. Most precisely, the paper also discusses possible ways to evaluate which effect sizes are interesting. It also discusses recommendation when you report a sample size justification based on resource constraint, what you could do when your sample size is restricted because of resource. It also discussed recommendation when reporting an a priori power analysis, recommendation when you justify the use of a meta-analytic effect size to estimate for a power analysis. It discussed recommendation when justifying the use of an effect size estimate from a single study. And finally, it gives recommendation when justifying error rate based on compromised power analysis. So you can have a look on the paper because some of this section might be useful for you depending on your particular situation. So here is the summary of the paper that Lakens preprinted just recently. And now I think we can begin to discuss regarding particular situation and regarding some situation we might face and how we can deal with this situation. For example, one of the situation we may face is when you need, I choose this one because this is one I faced very recently and that a lot of people can face, is when you want to justify a sample size with an a priori power analysis, but but an a priori power analysis is based on an effect size you would like to detect, to find. But what can you do when on the literature there is several effect size and heterogeneous effect size, for example, very small effect size, very large effect size? What could you do? So this is the first question I would like to discuss with you before moving to some potential solution. In your opinion, if somebody is here and have some opinion on it, what could you do when there is a lot of effect size and heterogeneous effect size on the literature, and you would like to use them on an a priori power analysis?
I suppose is one of the first things we look at, whether what's causing the heterogeneous effect sizes in the first place, because I imagine that a lot of it is going to come down to things like different groups, etc. Can we try to narrow down?
Can you repeat, Jaime? I'm sorry, I think the hearing is not very good, so I didn't understand what you said.
Can you hear me now?
Yes.
Great. I suppose before, when looking at this, is the first thing we need to identify what's causing the heterogeneity in effect sizes in the first place. Because I think with a focus on novelty all the time, it's hard to get exactly similar studies. So these heterogeneous effect sizes, are they based on, why are they heterogeneous in the first place? Are the different populations, etc.? I think that will very much dictate what strategy we take after that. I don't know.
Yes. So this is a first point that is rather interesting, because when you will have a look on the literature and there is several effect sizes, one of the reasons is that the different effect sizes came from studies that are different from what you would like to do. For example, it's different population, it's different. If I use an example from psychology, it could be different questionnaire that assess, for example, the same thing. You want to assess self-esteem, but there is a 3, 4, 5 questionnaire of self-esteem, and there is one with that produced a large effect size, one that produced a smallest effect size. So I think one of the first thing we can do is, and it goes with the Ricardo comment on the chat. It go to the, I think one of the solution when there is a lot of effect size on the literature and you would like to pick one to perform an a priori power analysis is indeed to choose one that is close to yours. So maybe, for example, as you said, I think, Amir, this is what you said, choose one, for example, with a population similar to yours, people that will look like yours, and for example, forget studies that are very different for what you would like to perform. Okay, so this is the first thing. You can go for a study that will really looks like yours.
If I could jump in for a second, this is, yeah, in my personal opinion, I really kind of tried, whenever I'm advising on not effect sizes, but really sample size justifications, is not looking to previous studies as far as deriving the effect size. Now, it may give us a reasonable heuristic, right? It may give us an idea of what people are hypothesizing that's out there, what phenomena you're studying. We shouldn't just ignore them, but I don't think just kind of recording all the Cohen's D's and then picking one or a combination of them is really an efficient approach. So my thing would be more or less, if you look at all those heterogeneous effect sizes, if that does exist, maybe it's like, what's the smallest of these that we would be still interested in? Because I think when you start looking at previous studies, you may pick one and think, oh, if they found this, so then I'm going to try to find that as well, which makes sense intuitively. But then you run into the problem of, you run the study, the effect size is, say, Cohen's D 0.5, but it's a non-significant effect because you have too small of a sample size. But you're still interested in an effect size that big, right? So that's why it always comes back to what's the smallest effect size of interest. Because yes, if you find yourself at the end of the study going, oh, well, it's non-significant, but it's important, then you've kind of set yourself up for failure. Just my 2 cents. But then there's the
Yes, so
issue
this
of getting the smallest effect size of interest.
Yes, this is one of the solutions that Daniel proposed on the paper regarding this point, is that maybe you can ignore the literature and choose an effect size, the smallest effect size of interest. So the smallest effect size that you consider meaningful, with meaningful that could have a lot of different meaning depending on the situation. But you can just pick an effect size that is for you meaningful. It could be, for example, practically meaningful, clinically meaningful. And so you will use this meaningful effect size, the smallest effect size of interest, to perform your power analysis. So yeah, this is a possibility. And one of the reason regarding it is because it's I like this approach based on the smallest effect size of interest, because it differentiates between the observed effect size and the possible effect size on the population. If you do a power analysis based on a past study, you justify your sample size based on what a past study found. However, this effect size that the past study found could be very different from the real effect size that you will never know, but you can estimate that in the real life, the real effect size is, for example, another co-ND. And so I think go for the smallest effect size of interest could be a good strategy. And it could increase your chance to find an effect that is maybe smallest than what a past study found, but that is still meaningful.
I think I fully agree from a kind of theoretical point of view. However, I think whether you work in kind of more health related or performance related studies is going to influence very much what you do here, because I think I'm thinking in kind of terms of my studies, my areas, say sports nutrition studies, somebody will always make the argument that from an athlete point of view, any improvement is going to be important. You can basically justify anything above 0 as a important, meaningful change if you bring it to an elite athlete and performance point of view. However, I think it's we've actually just finished an individual data meta-analysis where we're looking at some different ways to look at individual response, and I was really struck by just how variable it was and just how much sampling error can impact our individual studies. And I'm kind of coming to the conclusion that in some studies should we even be doing this, attempting to identify our smallest effect size of interest, particularly in the performance things, because people will say anything is interesting. We know sampling variability is huge and sampling error is so wide. Should we be even trying? Because it just always feels like guessing. Well, I think. Go, Aaron. Tell me everything I've messed up there.
No, then I think I agree with you to a certain extent that, there is this kind of in-between space, right? And I'm even fine with saying raising the type 1 error threshold, right, to kind of get that under. But if everything is of interest, then don't do the test. Just report your observations and say, do you know what I mean? Like there's a certain point where when you're testing things from a scientific perspective, if there is nothing that is going to make you change your mind that this could be effective, then don't do the study, right? So there's a certain point with sports science where I hear this commentary of, well, anything could work and we just, and then I'm like, well, then we're not really doing science. You know what I mean? So if there's no test, if there's no point at which we say this is no longer effective or no longer beneficial for anyone, then and I'm saying this from a perspective of I've had long days of walking and thinking about this. So it's not, I don't know. It's the kind of the conclusion I keep coming back to.
I think for some measures, we need to think about the measurement error attached to our tests, don't we? Because the smallest effect size of interest is whatever is above the measurement error a lot of the time. So if you consider, a VO2 max test, for example, if we use a verification phase after a VO2 max test, we look for, anything that's more than 3% usually, and I know there's some criteria that use 5%, but the 3% or 5% is based on the measurement error that you'd expect from one test to another, So I think for some of these things, we need to understand better the measurement error attached to the test that we're using.
Yes.
And
Another thing I would like to add regarding what you said, Emir, is if you consider that any effect size you can detect is meaningful, is interesting, I think maybe don't justify your sample size because of an a priori power analysis. So in this situation, for example, it's the first study you conduct, and for example, you have for the moment no idea of what you could find. Okay, so don't perform a power analysis to estimate to justify your sample size, but for example, justify it on a resources constraint. For example, you have 2,200 athletes. Okay, let's go for 200 athletes and then perform another kind of justification, but not on a power analysis, I think.
yeah, and I think for me, this is actually huge in that we need to know where our research line is, and we need to know what our question is. And I think it links back into our last journal club on Anne Shields. I think we've reached a point where, oh, justifying sample size, having a priority analysis is a good thing. Let's apply it to everything. But sometimes it feels like worse than not having anything at all. Like we're just doing it for the sake of it. And I think, again, where is our research line? What is our question? We probably don't need, I think it's sometimes more harmful than good to attempt to estimate these things when the research question, or the research line, I think it's where the research line is. More often than not, I think.
So yes,
Do
for
something else.
to just discuss what I see on the discussion, when Vanessa said you need to ensure that you are familiar with your measures, it catch up with a section of the paper we discussed today that is called Know Your Measurements. And so I think anybody that is interested in this discussion and error rates, I think we all should have a look on this section, Know Your Measurement, because it's very important when you discuss power analysis and estimation on an effect size. Okay. So does anybody has other comment or other potential solution to discuss when you face this situation?
I just have a quick comment regarding the resource allocation aspect. And I think it was good that Daniel brought that up in his paper, because I'm sure there's many colleagues in sports sciences that are in, let's say, an undergraduate institution, and they can only rely on thesis level projects where they have students from September to April, and in September they're putting together the ethics. They may only be collecting in January and then until April. So they might only have that limited window in which they can get a sample. And it does become challenging. And I'm not saying that these papers deserve to be published because they have that level of justification, which is a little lower on the spectrum that you provided. But it is worthwhile to acknowledge that that is a limitation that we face. And that's something that can be considered, whether it's just that preprint of that paper getting put out, but maybe not actually ending up as a published manuscript.
Yes, the next situation is based on the resources constraint, and I think we will spend some time discussing this particular point right.
You got me so excited. I had to hop in.
I know,
So,
I'm like, but I want to talk now.
I don't know how long we are in for the moment, 30 minutes. Maybe if you are all okay, we can move forward to the next discussion point. We would like to. So just to conclude on this section, there is this question. I put it on Twitter a few months ago, and I received 15 different potential solutions. So this was not so helpful when you have 15 possible solutions. But what we can conclude right now is to go with what Aaron said. So no, the first solution I could choose is to go for the smallest that is reported on the literature. There is a lot of sample size. There is one that is really small. Okay, for safety, with comma, just go for the smallest that is reported on the literature. Another solution could be to go one that comes from a reliable study similar with yours. Another possibility is to estimate a pooled effect size, so with a meta-analytic analysis, and then divided by 2. This was a potential solution. Set a maximum sample size you are willing to collect and perform sequential analysis. The paper from Daniel also discussed sequential analysis in this kind of situation. And the final one is one of the literature that is meaningful, with the possibility of the smallest effect size of interest, the smallest meaningful. Okay, so now I think we can move to the next situation we may face. Okay, imagine your sample size is limited because of resource constraints. What could you do? What could you do to, what I mean, but what could you do is what could you do to give to the potential readers information and information regarding the value of your results and the reliability of what you found. So I think we can discuss this for a moment. What could you do when your sample size is limited because of resource constraints?
I'll hop in. You can essentially minimize your combined error rates. So this is something I've incorporated within Superpower, which is well, actually so even people who don't use R, you can use the Shiny app. So let me pop that into the chat here. But you can essentially set it up where you have like a design, hypothesized effect, or smallest effect size of interest, either one. And then you can calculate standardized effect size and then say at what alpha level do I set this at where the combined error rate of the type 1 errors and type 2 errors are minimized. Or you could even do it like kind of what we do with power analysis now, which is a ratio of errors, right? Like how can I keep it where, you know, there's that 1-to-4 ratio of beta to alpha, if you will. That's one approach, but right now I only have it working. Well, you actually can apply it to more than just ANOVAs with some of the internal functions, but it's fairly limited in its use as far as if you're getting it in more advanced modeling scenarios.
Okay. So there is already a few remarks on the discussion. Collaborate with other labs, for example, sequential analysis, that could be a good option. Okay.
Cyril, I'd also have a think about, you know, the kind of your primary outcome and whether it's something that you can actually, you know, investigate and get value and add value, you know, with your experiments with a primary outcome if the resources are so constrained that you're going to have such a low sample size. So I think, you know, we need to kind of carefully consider our primary outcomes and I suppose our measurement, as I said, just to kind of, I suppose to throw another thing in there when I was talking about measurement error, you know, the smallest effect size of interest is an interesting kind of phrase, isn't it? Because interest to who is the big one. Is it the researcher? Like, so in the clinical world, it's not really, doesn't really care what we're interested in. It matters what the patients consider an important kind of change or a meaningful change. So, you know, and the clinicians to an extent as well. So, you know, there's a difference between what is noticeable by the patients and then also what is beneficial for the patients as well. So it's kind of, we need to consider effects that would be meaningful in a way that would benefit, you know, the care of patients a lot of the time. So if that is, back to my original point, if that means that you're going to need a massive sample size, well then for your kind of primary outcome, well then you might need to consider that you cannot do that study in the first place, you know, or definitely without, you know, collaboration with other sites and so on. Yeah.
Yes. So you think we should, in this situation, you think we should consider the fact that we just can't conduct the study because anyway, because of the resources constraint, the sample size we can reach is obviously too small, and the question we can't answer the question we would like to answer with a so small sample size. This is what you meant?
In some cases, yeah.
Yes. Okay. So yes, I think this is something we might consider. For me, I would like to open the discussion to a particular point precisely from a statistical point of view. When you have a very small sample size and you know that your resources are limited, I think one thing we can do is to think about design and analysis and question that are more powerful. And because and this is some I would like to drive the discussion in this direction, because this is something that is discussed on the on Daniel papers, is that with sometime when you change slightly the question, for example, your question could be on the differences between two groups, and if you move, for example, to differences between an individual at 2 points of the time, you will change your type of design, you will change your type of analysis, and you will most probably increase your power. And sometimes when your resources are too limited, and are not useful for your question, for another similar question, and for example, for within design compared to between design, you will increase your power without changing your sample size. And so this is, I think, something we should consider, because, for example, you have only 30 participants and it's not enough. Okay, so maybe if I conduct within-person design, what is my power now, and is it more powerful? So I think this is something we could consider, and maybe we can discuss this if you think this is interesting.
I wonder if there is always a solution to a small sample size we have. Shouldn't we invest the money in another study that may address the question better? I mean, at which point do we say, okay, I should not run this study? This is my question. At one point, we invest money. So at one point, we need to decide whether we want to invest this money in this study, low power study, or in this other study that address another question. So I don't know, is there always a solution to improve the power or something? Or at one point, we should say, no, I should not invest money in this one.
I do think that's really relevant for a lot of situations where I think a lot of the time we're trying to do very complex studies to try to really narrow down into the nitty-gritties of phenomena that we don't actually understand very well in the first place. Like, we're trying to figure out what moderates a particular phenomena without actually knowing if it exists. And I really do think that there's a lot to be said to bring it back to simpler questions, simpler designs that we can get a clearer answer on with the resources that we have, that can then build to the more complex designs. And I think as a field, if we can perhaps try to collectively value more the simpler ones, designs and questions, we can gradually get to the more complicated ones. I think would be.
I agree with you completely, Emer. However, people like Tal Yarkoni would claim that you're then contributing to the generalizability crisis, right? Because if you only are narrowing in one little area and focusing in that one little area, you may be missing the big picture, or may be tapping into an effect that's, you know, very specific to one specific way of looking at a phenomena. So it's a struggle, but I agree. And I think especially for sports science, where, you know, we're dealing with small populations, difficult to measure phenomena, and expensive to measure phenomena.
Yeah.
Right. It's not easy to just, you know, it's hard to do a lot of the stuff we do. Like, if you're putting in an IV catheter, like, you're not going to collect 800 people. You know what I mean? So
this is where I think the words we choose are so important, in terms of, I feel we'll only contribute to the generalizability crisis if we try to generalize beyond what we have. So I feel like being very clear about why this very simple design needs to be fulfilled, a question needs to be answered before we move on, shows the value of that alone. But I think that the problem is when we try to extrapolate our simple designs to the entire world. But maybe if we just accept that we're not going to change the world with every single undergrad study, maybe we just need to be more realistic, not to reduce the value of things, but to give more meaning to simpler things.
Yeah, I agree. And it's speaking, well, I think like this is something that I think is fairly complex, but it's really, I think, a simple thing to institute. I think for a lot of studies would be better off, not better off, or they could improve their research design by going with something like a replicate crossover study, where you're exposing everybody to the experiment when you can have a good washout period. So like training studies, this is out the window, right? But for like short exposure studies, something like replicate crossover, where you're exposing them to the same condition, more than once, so we can actually even see how much variability in the responses to the different stimuli or treatments, I think is really important. And it doesn't increase, obviously it increases each participant's or observational units, the number of times you have to observe the phenomenon, but you're still not increasing the number of people you need to recruit for the study. So yeah, I think there's a really good Steven Sen paper out there on that. And that's actually, it's really good for if you want to measure the individual responses to a phenomenon.
Aaron, surely you're not on Tal's side of the argument. Surely you're with Daniel on the generalizability crisis.
I think I agree. I think Anne once said, I find it, Anne Shiel was like, I find the disagreement a bit silly. I think the two of them are having fun with it all, I think, first off, but I'm kind of in between the two, right? Where like, I understand like, oh yeah, we can really miss the big picture sometimes and we should avoid making big sweeping claims, but sometimes we are better off kind of focusing in on something small and then building the blocks out from there. Because I mean, I think especially for our work, like we would have to wait 2 decades to do some of these studies because under Tal's like kind of like general wide swath approach, like we'd have to collect 1,600 people, dozens of different demographics before we could ever make any statements. And I just don't think that we're not going to move knowledge forward. And it's in a way that our funders would agree with.
Yeah. I like Daniel's, very short response to Tal in that paper. I can put it on the chat, but it was just basically summed up by just be sensible when you're trying to generalize your results,
Just to add a bit to that, even thinking from Tal's point of view, where he's discussing, general psychology. If we look at sports science, we're bringing people into the labs, and it's a lot more resource intensive, which makes it a lot more challenging to scale up and really have wide scale generalizability. So, within our own field, we have our own challenges that we need to face with that regard.
Yeah, I think that's a great point, Denver. Daniel's great. Loved it. There's a but coming here, but Daniel's great, and his work is fantastic and everything. The but is a general but, is that a lot of this kind of reform stuff is coming from people working in psychology, and it's a kind of different world, like to the clinical world. Some of these guys can run experiments tomorrow if they want. They can grab their students, they can easy measures, and they can get it and they can do it. And that kind of, even the frequentist stuff works well with them because they can repeat their studies over. Generally, they can do more experiments than I can, basically. So the clinical world, in terms of if I have an idea and I want to test that idea, well, then it could take a year or two before I actually set about answering that question, and there's no way clinicians are going to give me access to just some random ideas I might have. I've got to convince people beforehand and everything. So I just feel sometimes we need some of these people to kind of work within different areas, like the clinical world. Like you've got in the paper, and it's a great idea, like in terms of, it's a great point in the paper where it talks about the resource constraints, where, some data is better than none. And if you do enough, you can kind of combine them in a meta-analysis, and that's great, But like in the clinic, as I said, you might be 10 years plus before you get enough of those small papers answering a particular question, and there could be a lot of resources wasted. We know a lot about research waste, and, you could have wasted a lot of patient time. And let's say in the clinical, you could be working with metastatic cancer patients who don't have that much time, So, anyway, yeah.
Oh, I completely agree with you, Ian. And I would actually even say forthcoming paper, I don't have the data yet, so I can't speak to it, but I have a feeling that our literature and the problems we see within our literature are different than what is in psychology. As far as, I won't get into any details because I don't want to spoil some of what's coming with that, but I have a really good feeling that the problems we see, there's a lot of overlap, and then there's a lot of things that are not held. But I would say one of the big things here, as far as avoiding that generalizability problem and still working with our small samples where we can kind of move quickly but sustainably, and not overselling, is more open data. because I think that's the biggest problem I see is, we're making these small little looks at smaller groups, and then we want to generalize. Well, the best way to do that is then to synthesize. And right now, the resources out there as far as open data go are terribly bad. And it's going to be a long time till we get up, because we need to even create a system and norms for doing that. But I think that's one of the big things that we have to look to in the next 20 years is making sharing data the norm. So that way we can synthesize.
Of course, the data are available, Aaron. It's just reasonable request.
Oh, yeah. Although that has worked for me.
Define reasonable, Ian.
Yes.
I think
so
that
there is. Yes, I think this is a lot of things regarding this point. There is one final thing I would like to add, maybe not open to discussion, but just for later, is if you conduct a study and you publish it and you are based on a resources constraint, you will find an effect size. You will find something and you will have a sample size. In this situation, I think we should perform sensitivity power analysis that will tell us what effect size we are likely to detect with a certain power, and discuss this potential effect size we could find with a certain power with the literature. Is this effect size we can detect with, for example, 90% of power? Is it very different from the literature? Is it very similar to the literature? And so it will help us, I think, to transform an effect size we found and compare it to the literature and discuss this effect size we found with small resources. I think this is something we can try to implement on the on study where the resources are the justification of the sample size. Discuss the potential effect size you were able to find with 90% of power, for example. So this is just a point I would like to add, and if there is discussion on it, we can go forward. But I think there is not so much to discuss on it. And so, yes, as I said, a more powerful design with a similar sample size, this is something that is also discussed on the paper. So you can go have a look. Third question. So I think we already discussed this. But imagine you want to perform a study and justify your sample size with an a priori power analysis, but you have absolutely no idea of the effect size, what the effect size could be. What should I do? I don't know if there is a lot of things that needs to be added on it, but maybe if some people have other points to discuss here, we can. But I think Aaron already clarified this point. So if anybody, including Aaron, has a thing to discuss here, but I don't know. I can leave the slide open. There is a final question. So anyway, we can move forward quickly if you prefer.
I'll just add in here, do a pilot study and know your hypotheses, right? And if you don't know what the effect size should be, that's the time to maybe play around and learn the phenomena a little bit better. I think I mentioned it, Ricardo mentioned in the comments of like, you may not know and stuff like that. And that's fine. That's a good position. But then I just don't think you're ready to test the hypothesis yet. And it's the time to get into estimating and kind of, figure those things out and then do the big study that's going to test the hypothesis. My 2 cents.
Adding
So
to your
I
point,
think-
Aaron. Oh, go ahead, Cyril.
Okay, no, sorry. I think right now we have something to discuss, Aaron, thank you. Because you said do a pilot study. And for me, there is a real problem with the pilot study because most person intend pilot study. Okay, I will conduct a study with 10% and let's see what happens. And so this is, I don't think this is a good way to go because often pilot study are with very small sample size, and with very small sample size come not appropriate, not reliable effect size, completely different from the real world. And so you will build your real study based on an unreliable effect size. And so I think this is something we can discuss. If you want, we can move the discussion to pilot study for a moment.
Cyril, you bring up exactly what I was thinking, because does it peeve anyone else when you see these feasibility pilot styles or studies that get published in the literature and you're like, oh, okay, so when's the real one coming? And it never does. And you just have this massive effect size sitting in the literature that you likely know is never going to be followed up upon and shown to be different.
But like, is it also kind of a thing that most people label pilot studies as the ones that didn't work out how they wanted. Most pilot studies, from what I can make out, were never pilot studies. They were actual studies that didn't show an effect or had small samples, like, oh, we'll just call it pilot.
Yeah, I was on a thesis committee that said exactly that. And I was like, you're graduating from your master's and moving on to OT and labeling this as a pilot study, but I don't see anywhere in the future that this is going to be actually conducted.
Yes.
And let me be clear, I do not believe in taking the effect size from a pilot study and using it for your future study. That is a suggestion to understand the phenomena better and then give yourself some kind of mental bounds and heuristics to be like, okay, what's reasonable for an effect size? Because, you know, there's one side where it's like, don't use the pilot study, but also you've collected data on 10, 12 participants. That's still information, right? You know more than you did at 0 participants. It'd be silly not to use some of that information. But
at least it can tell the direction, maybe not an accurate magnitude.
Yeah. A direction, a reasonable, like, I mean, you can put confidence intervals on the variance too, right? A reasonable idea of between and within subject variance, or either or, depending on what the study type is. So yeah, you can do some things with that, but just don't think that that's going to reflect the exact reality of the population you're studying.
Yeah, don't throw out a good idea
Sorry.
on the basis of people doing it poorly. You know, like Aaron's right, into like a pilot is a good idea, you know, in a lot of situations. It's just that you have to do it right. And, you know, you're not supposed to do hypothesis testing on a pilot. That's not the point of it. You know, the feasibility is to determine whether it's possible to run the study in the first place. And the pilot is, you know, a small version of what the main thing would look like, so that you know that the kind of processes work, and then you can kind of get some idea of the variation in your measures and some estimate of the precision of the measures as well. Like Aaron, yep.
Determine what the primary outcome is going to be. Like, I feel like sometimes you have a lot of studies where you're like, there's these 3 things we kind of want to measure, or like you have psychometric scales and stuff, and you're kind of trying to determine which one, and then you'll get a better idea from the pilot study how they're responding, what the distributions are going to be, and that's what. So then for the real study, you know, like what model I'm going to use, which one's the primary outcome, those kinds of things. That's what a pilot study's for. And when you're publishing the pilot study, it should be an open discussion about, like, yeah, we don't feel like this scale worked that well, or this test or that. You know, those are the things to publish and talk about when, you know, writing up pilot studies, not, oh, the effect size is Cohen's D7, right? Like that.
Sometimes it kind of feels like every one of these questions kind of comes back to the same core solution of the language we choose to describe what we've done, and to avoid overemphasizing things. Because I think everything we're talking about here, okay, Ian, absolutely, just because some people don't describe their pilots correctly is no reason to throw out pilots. It just feels like always the problem is when we extrapolate beyond what we have, which I think is environmental to an extent, in that we're encouraged to have novelty and to show value. And I just think that if we can value the simpler stuff better, a simple pilot that allows you to identify your outcome, that is valuable. We need to stop having incentives for people to extrapolate beyond what is. Just do what the research line needs and report what you have in the way that makes best sense. Like, we don't always need to build everything up into something more than it is.
I just want to comment on Brian's comment about should pilot studies ever even be published. My thing is, I'm sure maybe some people will agree or not with this, but in kinesiology, it's almost like we salami slice things a lot more than psychology, that has these, you know, 3+ study papers. And maybe a good solution to this is that we have a study 1, study 2 within our papers, where study 1 is that pilot study, and then study 2 is where you build upon that. And that might be a good way to go in the future.
I completely agree. I really love that approach. And if you look at the basic scientists in our field, the ones doing like the cell and animal model studies, that's what they do a lot of times, right? Is they'll do an experiment, then they'll go over to a cell line, do another experiment, and then their whole discussion is talking about this led us to here, and therefore with all of these experiments together, we believe X, Y, and Z. And I think
the problem is we're just sucked into the sin of bean counting, essentially, if you want to go to, you know, Chris Chambers.
Yeah.
But I think it goes. I think it goes back to the last journal club where you discussed a dichotomous conclusion based on a single study. I think because this is what you said, Iron. I think there is one study and the second one and the third and the fourth, and then you conclude something and not the first. This is the pilot. There is 10 people. Okay, I think it is like that, and we make a dichotomous conclusion based on it. So I think it goes back to the last journal club you had based on that was on the dichotomous preprint, I guess, but I may be wrong. And if it's not, there is a paper on dichotomous conclusion based on one study from Daniel also that you can have a look if you are interested in. So I think I will just move forward to the last question of the journal, today's journal club. The very last thing you can consider if you want to perform a study and justify your sample size on an a priori power analysis is to forget maybe the power analysis and do a sequential analysis. This is something that is discussed on the paper. I'm really not an expert on it, so I think you can just have a look on it, and maybe it could be useful for your approach. Okay. So the very last question is, I would like to discuss is, imagine you know exactly what you want to investigate, what is the effect size you want to investigate, but the planned analyses are very complex. For example, you would like to perform multi-level modeling with 2 level, 2 random effects and 4 fixed effects on your multi-level regression that obviously JPower doesn't allow you to do if you want to do an a priori power analysis. I think it will just burn if you try it. And so what should I do? What should I do? I know exactly what I would like to test, but I'm absolutely not able to test it. What should I do? Let's go on.
Come to my talk tomorrow through the riots at Exeter Club. No, simulation. That's my approach, at least. And it doesn't even have to be with the package. Oh yeah, and Sam's even in the chat saying it. Yeah, simulation. And I know a lot of people in here may not be aware of how to do simulation. Guess what? I wasn't 3 or 4 years ago. And I learned, and it's not that, yeah, and collaborate with a statistician. You can also just reach out to someone like myself to help you write that code. But really it's not that complex. And once you understand like the underlying functions, both in what you're trying to model with the multi-level model and the data generating processes, it's not that, it's not too difficult.
Yeah,
but that's my suggestion.
This is very interesting, Aaron, because when I built this question a few weeks ago, I was like, let's discuss it because I just don't know. And very recently, there was some papers that was published. So the two that just appear right here that are power analysis based on simulation that gave you a very easy tool to estimate your power based on simulation for example, multi-level modeling, for structural equation modeling. They are very recent. I think it's 2021. So this is really recent. So this is maybe something you can have a look on it. And so here, the fourth suggestion I made is maybe I think right now is completely not useful and not relevant because this is what I thought before this paper was published. So I think, yes, the simulation ID, I think is the way to go right now, and maybe collaborate with a statistician, yes. If anybody wants to add some things on it.
I will add that if you're looking at multi-level models, the SIMR package in R, SIMR, is amazingly good and flexible because it's not just limited to like your normal Gaussian distributions. You can have binomial, Bernoulli, Poisson, like anything that's supported by the LME4 package, it will run. Now, mind you, if you think it's difficult to set your predicted means and standard deviations for superpower, this one's going to be on a whole nother level with the multiple levels of variance. But it can. Oh, thank you for adding the tweet there for me, Denver. But it can do quite a bit. And then the other thing to look at is the sim study package in R, which is also extremely flexible in what it can simulate. I tend to use sim study and write my own custom code, but Simmer is really good in situations where I'm a tad bit lazy and don't want to write out the data generating process myself. So those are my two suggestions. Now, for those of you who don't code in R, I don't have many solutions for you. I'm sorry.
I've got a question for Aaron, given that he's here, and it's more around the kind of theoretical information that's needed before you plan this kind of complex analyses. So when you're working with, you know, a researcher, and when they're trying to decide kind of multi-level stuff and what goes in and what level did it go in, and also like, how do you have that conversation where, like, you know, do you ask them for evidence for their decisions in terms of these things, and how strong and maybe what they're leaving out in there as well? Like, how do you go about that, Aaron?
Yeah, we specify everything. So I actually will have, so this is what I have a lot of meetings at my job at the Army Research Institute, where it's just where we're sitting down and I'm writing out well, not on a whiteboard now, but I'm typing it out on the screen, where I'm writing out like the model and saying like, you know, the slope, you know, these error terms and stuff like this. And I, you know, kind of specify and get them to nail down through kind of like an interviewing process, like what's the slope here? Like what's the smallest slope that would be in line with what you're hypothesizing, right? And then sometimes the result of that meeting is we go to like more of an accuracy and parameter estimation approach, where I'm just essentially saying like, we're not ready for the hypothesis test, let's go do estimation. And then other times, but otherwise, when we're testing hypothesis, it's actually writing out the full model, getting out all the ideas of variances. We'll open papers and discuss and say, that's reasonable, that's unreasonable. And then the biggest thing here, it's what Eimer kept saying, it's about language. And so when you're reporting, I mean, because who are we trying to justify this to? We're trying to justify it to our funding agencies, to our participants, so that they know we're doing something worthwhile. And really, we're trying to justify it to future peer reviewers and saying like, this study was set up to actually accurately test this question. And so being specific about all of those things and saying like, the study was set up for this amount of variance here, correlations, covariance here, and these, you know, fixed effects, right? And if you specify all those things, I don't really think any of those parties have much to complain for, so long as you can justify all the reasons. And the justification just can be as simply as, you know, like, this is kind of what we're seeing in the literature, and this is kind of a liberal, you know, bound for this. And, you know, this effect size would roughly equate to this much benefit, right? And anything smaller than that, we just either can't detect or we're not interested in whatsoever. So just, you know, like Eimer was saying, just being as open and honest about that process as possible of what you actually were planning to do and planning to see. See a question about bootstrapping. Bootstrapping is great. Never going to, it's computationally intense sometimes. But I would highly recommend doing that for just about anything, because usually the parametric kind of approach and formulae can mislead you sometimes, and bootstrapping can show you that and why. So yeah, always recommend it. Oh, the actual power you've achieved. I'm not sure. I'm not a big fan of post-year, like a post hoc power, but I don't see how bootstrapping could necessarily be used for that. But if you have a paper, I'm happy to read it. Like, that's on that topic. Sorry, I didn't mean to take over there, but I just was answering the question.
Can you?
I think. Yes, sorry, Vanessa.
Oh, sorry. Just like to follow up on your comment on you don't like post hoc power analysis.
Yeah, I think if you don't have it, it's simple as this: if your effect's non-significant, you're underpowered to detect that effect. If it is significant, you're adequately, well, or almost adequately powered, at least, to detect that effect. So doing post hoc power is just a transformation of the p-value. So it's kind of a moot point. And it's why I said at the beginning, don't use a previous study, use your smallest effect size of interest, because you never want to be in a situation where you get a non-significant effect at the end of the study, and then look at the effect size though and go, wow, but that's still worthwhile, right? You don't want to be in that situation. So what you really want to do is design your study so that way you most likely wouldn't be in that situation once the data is collected and is in.
Yes, this is what I wanted to say. Actually, if you conduct a posteriori power analysis, a post-hoc power analysis based on the effect size you found, it's just another way of saying you have a p-value significant or not significant. You will find the same thing. But actually, if you conduct and Aaron, correct me if you think I'm wrong, but if you conduct a post-hoc study to find what power you reached based on an effect size of another study, of for example, a meta-analytic study or a smallest effect size of interest study, here you will have another interesting information that could be informative, but I'm not a big fan of post-hoc power analysis, especially if they are based on the effect size you found.
What about Aaron? So you want to assess the power that a number of studies in a, let's say, a meta-analysis, for example, you want to look at how much power they had for their analyses, or in just in the field in general. So Kate Button's paper looking at, I can't remember what field it was now, could be neuroscience. Yeah. So sure, that's okay though. Yeah.
There's been a little bit more of a debate in that area, and this whole kind of like I can't remember. It's like PPV is the acronym, and it's something about like post-predictive power or post-predictive value of a study.
Positive predictive value.
Yeah, I think it's post-predictive value, and there's some debate there. I just think when you're kind of looking at things backwards from a stance of power, it's kind of difficult because, and I think also with those other studies, you're also telling another researcher, well, you weren't powered. It's equivalent to going, well, you weren't powered for the effect size I was interested in, which may be a legitimate criticism. But I think in most cases, it's all in the eye of the beholder. I think it's way more interesting, in my opinion, to kind of look at, and there's even controversy around the P-curve stuff, but where those distribution of p-values lie and if there's selective reporting, right? If everybody's just coming in below the threshold and reporting there, then you may have a selecting reporting issue. And I think that's, way more of value. And again, if you have a lot of small sample sizes in a meta-analysis, the confidence interval, even on the combined effect size, is going to be quite wide. I don't know. I'm really starting to question a lot of that post-predictive value stuff, especially with some of its creators' recent scientific contributions lately. John Ioannidis, if anyone's wondering. So, yeah.
Yeah, well, Cohen was doing that before Ioannidis, wasn't he? Cohen was one of the first to actually, look at the power within a field of studies within a field. I don't know what method he used, but
it's that again. It's going back to like what you're assuming in the analysis, like because I think from Cohen's perspective is like most effect sizes are reported are in this range, yet the sample sizes are this small, so there's a disconnect there. So I think if that's I don't know. Like I said, like I think it's very situationally specific. Right, there may be a case where if you're seeing a lot, and you'll probably see that selective reporting issue with the p-values as well. In that case, is if you're getting a lot of like smaller effect sizes, right? Like let's say like below Cohen's d.5, and the sample sizes are all 10, 12 or less per group, then yeah, like that's clearly an issue because then you're looking at something very small and also using a very small sample size, and those two are discordant, right? Like the smaller you're trying to look, the more specific you're trying to look, the bigger sample size you're going to need to really get an accurate estimate of what's going on there. So you and me have talked about this before, and it's something that I haven't made up my mind on. I just feel it makes me feel very uncomfortable and kind of icky for whatever reason.
I know. You see, I want to do it. I want to do a study that looks at the power, in a field. That's why I'm thinking out loud. It's on my list of things to, things to explore.
And so here's one way to look at it. And so it's something that keeps getting brought up here. And I mentioned earlier is people always talk about, well, in sports science, and we're interested in very small, like if you could get a millisecond on, if we can just get, a 1% body, like all these small little effects we always say we're interested in, but then we use small sample sizes for. Right. And so I agree with you there in that, we keep talking, it'd be really good to show like what we're actually powered to detect in most of our studies, because it's probably somewhere on the lines of like a standardized effect size, Cohen's D of like 1 or above. So there, my thing is just like, if you want to talk about small effect sizes, you have to have very accurate measurement tools, very, low within subject variance, and also collect a lot of sample, like very large samples. So I think it'd be very good to show like that sliding scale of like the percentage of studies that are able to detect those effects. And my guess is a very small proportion would be able to detect those very small effects that in the literature we claim all the time are what we're looking for. So
but it's going back to the point earlier, Aaron, isn't it? That point 2, that may not be a noticeable change. Like, what is that in the actual measure that you're using? And is it noticeable? Is it beneficial, and so on? Yeah.
And I completely agree. And that's the thing with these small effect sizes people talk about in the literature is I'm like, I think our athletes, I think our stakeholders actually want big effect sizes, because, if you look at a Cohen's D and then convert it to a common language effect size or probability of superiority, like if you have a Cohen's D of 0.5, you're only looking at, I think, like 65% probability of superiority with like within a within group study. And I think if you gave an athlete those odds, you'd be like, they're like, no, I'm not going to invest in this hundreds of dollars a month supplement plan for an effect that small. You're going to have to double it, the effect size. So I agree with you that noticeability of the effect is very important.
That's why that or psychologist, website.
Stuff, Magnuson.
Yeah, it's like
fantastic, really nice.
Yeah.
I think
I think we need to let Cyril wrap it up, and then
Yes.
because we're after 9. I just want to be mindful of people that need to get off but don't want to miss any of the discussion.
Yes. So anyway, I think we reached the end of this journal club, and everything was really interesting and good discussion. So thank you very much, everybody, to attend to it. And so, yes, I think there will be like some kind of combination of everything we discussed with the package and resources and the article that Vanessa will do, if I understand correctly.
Guys, before we go, can I just ask our next journal club, we're planning to discuss Tagliacone's generalizability crisis, and I'll circulate the link during the week. If anybody is willing to suggest a paper or volunteer to lead a journal club, could you please get in touch with me and we can get that scheduled. Also, just a couple of dates for the diary. Next week, we've got Jenny Murphy, I see she's here, is going to talk about the Replication Centre in Dublin. On May 5th, we've got Daniel Umpierre from here in Brazil, who's going to talk about the Strengthening Evidence and Exercise Science Initiative. Other speakers that we've got lined up is Graham Close, James Betts, Daniel Lakens, Hagstrom. We've got some really nice ones lined up. So I just keep following us and keep releasing the calendars and dates. But yeah, anyone who wants to lead a journal club, give me a shout and we'll get it scheduled.
Thanks, everyone. And I put a link. If you're not a member, join us as we roll forward. All right. Have a wonderful weekend or week, the end of the week.
Bye-bye.
Thanks, Cyril.
Thanks so much, Cyril. It was really cool.
Can you write the Twitter of the company, of the association in the chat, please?
Hmm?
Can you write
the Twitter handle?
Yeah, okay. Thank you. It is it's not the Twitter. Oh, it is the website, but do you have a Twitter, right?
Yeah, sorry, at STORK Kinesiology. Sorry, I'm on my phone here.
Thank you. English is not my best point
There we
in my life, but thank you. Thank you. Bye.
Thanks, Cyril. Thanks, everybody. Bye-bye.
Thanks, bye.